on, Turbo 350Z time. So I pulled the radiator out of this thing to pull the crank pulley out of it because we're gonna have to make a trigger wheel for this thing. And there's no trigger wheels in the market except for some like ungodly expensive $1,000 one. So I have my trigger wheels and I have my crank pulley. Problem is the crank pulley doesn't have anywhere to bolt trigger wheel to, which, you know, is what it is. So here's my thinking. My thinking is I'm gonna drill and tap a hole in the middle of the crank bolt, thread a threaded rod in there with a lock nut so I can lock it in place, and then bolt it down in the middle, and then just put a tack weld to hold that onto here so it doesn't shift around once it's centered. And then if the pulley ever needs to come off again, it's just, you know, cut that little tack weld off, and then that's the end of that. Because there's plenty of places for me to mount a bracket to. So for instance, we've got 2 holes here, we've got a hole here, we've got this hole here. So there's a decent number of places where I can attach a bracket. So the bracket's the easy part. Whip one up in CAD in a short minute. It's the issue is this. So I gotta play around with this a little bit. I have some M10 threaded rod from a previous project which would work for this. It's just gonna be difficult to drill through this. I'll see if my lathe can do it. Yeah, gonna have to see if my lathe can do it, because we're gonna have to go in at least through that head, so that we can get a decent amount of threads in there so that I can really tighten this thing down. You know, just another day making custom stuff. Talk to the machine shop, and what I'm gonna have them do, because I just don't have the equipment for it, is we're gonna drill and tap 2 holes on opposite sides of this pulley, just like how the Nissan Jukes have. And if they can do it easy enough, we'll do all 4, and then, you know, we have 4 different places we can bolt into this. That's gonna be the easiest solution, because all the other solutions require, well, welding, and that's not gonna work, because if I don't have it perfectly centered, you're kind of screwed, and you gotta be able to get the bolt hole in the middle. So I'm gonna send them down this bolt in case they want to bolt it down to something, and then 4 of these bolts so they know what thread pitch to use. Is a 6x1, and then that'll be that. I can't do it myself. I don't have the equipment for it. My little CNC mill, I won't be able to bolt it down and then reach in there. I also don't have the bits or end mills to do it. The way I would do it, or have to do it, is clamp this thing down and like mill an area flat on each one, and then drill the holes in and then tap them. And if you take off too much material, these are already really thin. I don't want to make it too thin, because then you start running into issues. My idea that I just had about drilling into the center of that, it's got too much room for vibration and wiggling around, even if it's resting on the rubber of the damper. So that's going to be that plan. Just got this back from the machine shop, and the way that they ended up having to do it was how I originally mentioned, and wasn't sure if it was going to work. The noise you're hearing in the background is a CNC machine. So we have our pulley back. I sent it to a machine shop, and they did my original idea, which was to drill and tap the middle of the crank bolt, and then they put a stop in here so that it can't rotate, which I didn't think of, which was one of the things I was worried about. I went and catted up this bracket to go here with the standoff, but it ends up being simpler to just do that. For time's sake, it's a 3/8 thick piece of aluminum. We have stainless steel standoffs, stainless steel hardware. The CNC machine is currently cutting the part that actually holds the crank sensor, sorry, which will go here. And I ended up making it so that by changing the length of my standoffs, I can actually use the same holder that I use for the Jukes. So that worked out. So that's cutting. As soon as that's done, I got to weld it onto that plate, and then this thing is ready to time. All right, so we have our crank sensor on there, and that is secure. It doesn't even want to move when I'm grabbing it, so vibrations won't be a problem. So I got to hook up 3 wires, and this thing is ready for setting TDC. I have a TDC mark on the factory pulley. It's right here. So what I got to do is just rotate the crank a little bit to line that up, and then we'll put this back on. And what I'll do is I'll mark a line on here and a line on whatever tooth it is, and that's my TDC mark. We just have to make those line up. All right, so we actually ended up putting a little mark here so it line up with the factory HR timing indicator. Just that like bump you can see there. So it's all set. It's offset a little bit from when I torqued this down, but that's all ready to go. We got the wire ran, so we got to hook up the wire. Once that's hooked up, I gotta wait for somebody to get here to help me so that we can just do the base timing on this and base timing on that. And then we'll have all kinds of cars running in here. As soon as the base timing is set on this one and it fires up, emphasis on that, we can put the radiator and the front end back together. But I wanna get it running first in case there's any issues with this or if I need to check the timing. All right, sorry I didn't film a lot of the dyno stuff. I wanted to just get this thing done. So we ended up making 350 horsepower over and over and over again. The torque basically the same. We ran into an issue where this car's out of fuel pump. The guy that when he bought it was told there was a 340 LPH pump in it, but as you can see from this video, the fuel pump can't keep up, and I kept having to add fuel. These are 1080cc injectors, and they're at 80% duty cycle right now in order to keep this thing fueled up at only 10 pounds of boost. So the fuel pump needs to be made bigger. Otherwise, the car did great. Fuel tech worked great. It was very actually easy tuning session. It only took probably 6 pulls total. Then we did some drivability tuning right afterward. So what we're waiting for now is we have to send the FT450 out, have it modified so that it works with these coil packs, which is a whole thing. Then we'll put it back in, and then this car is ready to go. I got a couple little teeny tiny things to button up once I get the FT450 back, like in the interior. But this thing's ready to go for now. It is going to be coming back. We're going to redo the entire exhaust system and turbo setup and make this better. But for now, the car is actually safe to drive. On his previous tune, if you want to call it that, the car made 300-ish horsepower on my dyno at the same boost, but like it struggled to get there. So we picked up 50 horsepower, picked up 25 foot-pounds of torque, and it drives so much better. And a lot of that came down to the tune was just really bad that was on it. So, you know, when you build a car, make sure you do it right. So fuel pump, new intake manifold coming up, and then we'll do a whole turbo system, but that's going to be in a couple of months because it's going to cost quite a bit of money. But for now, this thing's pretty much ready to go. He's going to get it back at the end of next week.